ugBasic Game Programming Number 2, Exploring Atari 8-bit Color Graphics, coming up next. Last time we left off having loaded a very simple PNG image, and we displayed the compiled bits and bytes in the Atari emulator. Today we'll explore a little bit deeper into ugBasic's current capabilities with Atari 8-bit graphics. But I'll tell you up front, it's not as clear as I had hoped, but we'll keep making discoveries as we go forward. Let's get started with exploring Atari 8-bit color graphics in ugBasic. Supposedly, the ugBasic language provides access to all documented Atari graphics modes. Here they are. So, here's all the Atari Antic graphics modes. As you can see, we have access to basically 14 graphics modes. Unfortunately, they say up here that you get to them using the screen number command. I have not been able to figure out how to do that. In fact, I don't see a screen number command anywhere in the documentation, yet there's still more documentation to go through. If you use the Atari 8-bit for a while, you know that colors are limited if you're just basically doing bitmaps. If you add in the player missile graphics and the ability to use the display list, you can have 256 colors on the screen. But if you're coming from a layman perspective where you're trying to make something that works with a bunch of different computers at once, you're just using the built-in capabilities, you're going to get these maximum 4 color graphics modes. Let's take a look at color and see what ugBasic supposedly is capable of. Let's go through their colors. Okay, here's what they say. The pen command sets the color of the text on the console when followed by the color of your choice. The default setting of the pen color is default pen, and alternative colors may be selected from 1 up to pen color choices, depending on the current video mode. Alright, I'm not 100% sure this works this way on the Atari. I can't even run this example here. We can try it. It does nothing. In fact, let's try it, and I'll show you exactly what happens when you do something like this. So today we're going to be using the online sandbox a lot. We're not really going to be using the IDE like we did last time, but we'll see that some of these examples don't work on the Atari 8-bit. So if we paste this in here, paste, this is supposed to go from 0 to 15, showing the pens and printing something out. This doesn't work. This would work on a Commodore 64 maybe, but not on the Atari 8-bit. So let's go and we'll compile this in the online sandbox, and then I should be able to open it right away on the Atari, my emulator. Here's my Atari 8-bit emulator. I think I had made it smaller last time. Let's go here. This is what it does. Nothing. It's only a black screen. So that sort of going through the color indexes doesn't really work on the Atari 8-bit. So we're not going to do that. But what we're going to do is continue on, and we're going to read through what else they say about color. Then we're going to do our own tests. So this is what they say about background color. To select a background color on which your text is printed, you can use the paper command. The command is followed by a color index number between 0, it should be between 0 and up to paper colors, depending on the graphics mode in use. In exactly the same way as pen, the normal default color index default is paper. Okay, I don't understand anything what that's saying, but I can tell you that when I try it, it doesn't actually work this way. In fact, I think the colors on the Atari 8-bit are basically set from 0 to 256 or 128 based on the color index, and then 16 or 8 luminances. I think it's 16 because it's GTIA, so we're at the 256 colors, but we're going to get to that and we're going to test it. This is how you do text. So let's see if there's any text version we can do. I think I do have a text example here. Let's do this one. Here's an example using text in the Atari 8-bit. So paper 0, pen 15. If you know anything about the Atari 8-bit graphics, let's look at this really quick. This is from the book, Stephen Levy's second book of Atari graphics, and this shows that here's our color indexes 0 to 15, so there's 16 basic indexes, and then depending if you're on CTIA or GTIA, you have 8 luminances between these. So gray, if you're in GTIA, gray 15, which would be, let's look here really quick, let's go back over here. So pen 15 would be white because it's the 15th luminance, which is the whitest you can get of black. And black is the paper. You only get one color. So if we're on pen 15, that's going to be white, and we're going to do whitish text. So let's take a look and see what happens. There we are. Whitish text on black. Now, can we have a different color on black? This is something, let's try this. Let's do pen 30. So that's the next color. What should that be? That should be the brightest gold, or the whitest gold. So I don't know if that's going to show up. If this should not probably work because the text mode shouldn't have this other color in it on black, but let's just see what it does. This is just a test. So nope, it's still going to be white. So basically it's the highest luminance of black because you only get 2 colors in this mode. Okay, so let's go to the colors when you're using bitmap graphics. I have a little thing about colors here because they have these preset colors, and it says this section explains how ugBasic programmers are free to exploit the color handling features. Although various targets provide different color schema and registers, ugBasic allows the use of colored numbers ranging from 0 to screen colors or color count. Kind of. I mean, to me, there's 4 color registers in the Atari 4-color mode. So they should go from 0 to 4, and you should be able to preset those registers. It doesn't seem to me this works that correct in ugBasic at the moment, but we'll see as we go, and we're going to be making discoveries. But you are not restricted to the preset colors. So what that means is they have colors like red, white, orange. So we're going to play with some of those, and then we're also going to use the color numbers that I discovered. You're not restricted to the preset colors that have been allocated for drawing operations. The ink command is used directly to specify which color to be used for subsequent drawing. The number of the color is set like this: CLS, color back red, ink yellow, and this draw to is not going to work because they don't actually give you a draw to, but I have my own version of this. So let's do this. We're going to take this exact example. We're going to make it actually work on the Atari, which is going to be a little bit more like this. So bitmap enable 4, that's give us a 4-color mode. Clear the screen. We're going to make color back red, ink yellow, and then we're going to draw a box from 0, 0 to 10 to 10, 10. So let's do this. There it is. So that actually works. So this is our bitmap mode. We have a red background with a yellow box. Okay, that worked. There's an example in the section on graphics that does print some horizontal bars, and it's supposed to print them in white on the screen. But if you look at this, let's check this out. This is bitmap enable 2. Clear the screen. It creates a constant for bar width of the screen width divided by 10, and a constant for the bar spacing of screen width divided by 5. So it wants to print as many bars as it can on the screen with spacing of 10 based on the width and heights. A width, so that's a very dynamic version of this code, and it wants to do them white. But this is on the Atari 8-bit, and so you only have, in this mode, you only have 2 colors, and I'm not quite sure why it's this mode for 2 colors, because I would like to do the high res, but this is not a high res mode, I don't think. Let's check this out. So here's orange on black. That's not white, but if you look at the code, it's set for bitmap enable 2. So let's try bitmap enable 4, which is a 4-color mode, and see if it actually can do white. So let's try that now. Okay, let's try this one. Ah, so if you use 4 color, you're going to get white. Very interesting. Okay, instead of ink white, let's do ink 15. That should be that 15th lumen or the 16th luminance of black, which is white. I know this sounds strange, but if you know the Atari graphics, the luminance, the color 0, hue 0 is black, and when you get to think of black on a RGB spectrum, where the most white in black is white. I know that sounds weird. Okay, it did do white this time. Oh, well, it worked. So that's ink 15. So that leads us to some other stuff we can do. Let's try some different colors. Let's do these bars in blue. So let's try blue. And actually what we're going to do is let's try a little bit different. Then we go down here and let's also print what blue is. If you do this, this will print out the actual color number of blue. And we can figure out if this works on the Atari 8-bit spectrum. Like, where's this blue showing up? So let's build to the Atari 400 800 XL XE. Okay, so this looks purple to me, not blue. And this says color 116. So if we go back over to our graphic that we have up, 116 is 116 divided by 16 is 7.25. So in the middle of blue, it should be 7.25, but it looks to me like we're in purple blue. So I don't think this number works exactly. This 116, but let's try red and see where red shows up. So let's try red and red. Okay, so let's try this. All right. So there, red shows up, and what does it come out as? 68. So 68 divided by 16 is 4.25. So if we look back over here again, between pink and violet would be red. If you look, there isn't any other. Well, 3 is red orange. So are these off? Am I 0? Well, anyway, it's okay. It looks to me like the hues may be a little messed up on here for the Atari, but it's kind of working. So instead of worrying too much about that, let's get to our first real example. Let's do something real. Okay, so let's draw a red box on the screen. So, and what we're going to try to animate this box. So here is our red box. Bitmap enable 4, clear screen, ink red, box 00 to 55. So let's go here. Okay. Let's get a little coding done today instead of keep on looking at these colors. Okay, there's our box. Interesting little box, right? It's in the top left-hand corner. Let's try to figure out which mode this is. I think we can print out the width and height. Let's see. Yeah, let's do this. Let's do at the bottom of here. Let's do print screen width, print screen, just to see where we are. So what mode is this? This is a 4-color mode. I probably is going to be 160 by something, by 192 maybe. 160 by 96. So 160 by 96. Got it. Okay, so we want to move our box on the screen. All right, so it's a little bit longer. It doesn't let me extend this box, but we can see. So what we're going to do is we're going to do bitmap enable 4. So we're in this 160 by 92 mode. We're going to dim x as an integer and y as an integer. Then we're going to set x and y to 0. That's going to be the top left corner of our box. So it's going to start drawing in the top left corner. Then we have a label. This is called a label. This is used for go-tos and go-subs. A label of main, and this is so we can loop. So first we're going to clear the screen. We're going to set our ink to red. We're going to draw a box from 0, 0, because that's what x and y are at the beginning, to x plus 5 and y plus 5. So that's going to be 5, 5. Then after we've drawn that, for our next loop, we're going to add 1 to x and add 1 to y. And then if x is greater than 100, which we can't do because we're going to go if x is greater than 25, then go to end. And at end, then it's going to be done. And so if it's not the end, it's going to wait 50 milliseconds with this wait command. And this will go back to main, where it's going to reprint the box after clearing the screen at its next position. So let's see what happens here. Oops. Expected end. Oh, okay. Sandbox, how it does its errors. You can tell right here that it said expected $end here. I've go to should be in capital. Okay, that was from my notes done wrong, but this is good to show how the sandbox does errors. All right, so here's our box moving across the screen, and then it stops. Okay, flickers a lot. That was brute force. What we're going to do now, instead of that brute force, is we're actually going to just erase the box, not the entire screen. So we have to add a little more code for that. So let's go through that here. To do that, to do what we want to do, is we're going to bitmap enable 4. We still have our x as integer and y as integer. Then we have these two new ones. Dim old x and old y as integers. This is going to hold the last position of x and y, so we can use that for erasing. So we're going to set x to 0 and y to 0. We're going to clear the screen. We're going to have main, and we're going to start ink as 50, that's red. We're going to draw our box like we did before at x and y. But then we're going to set old x to equal what x currently is. We're going to set old y to equal what y currently is. Then we're going to do x equals x plus 1, y equals y plus 1. If x is greater than 100, which doesn't work, so we're going to do, let's do 50 again. Then go to end. If not, then it's going to wait 50. It's going to set ink to the ink 0, which is black. Then it's going to draw a box over our old space, so the old box, to erase it and go back to main. And this should, without clearing the screen, be a little bit better. It's not that great, because I've run this before, but it looks a little bit better. We'll find better ways to do this. But for now, this is sort of like the basics of trying to... There it is. It moves a little bit better. In fact, let's try and run both of those sort of at the same time. Let's see, how can I do this? Okay, so let's go back up here. Let's run the old one first. There's not a big difference there. Although it's better, it's going to be more throughput here. We're going to be able to put more stuff on the screen this way. But we'll figure out. I would love to double buffer this. So what we would do is we would draw this box in another space, move it over so it doesn't see it drawing. Probably would look a little bit better. But these are going to be our tests on the Atari 8-bit. Can we make something that doesn't look flickery as a game-wise? So next time, we're going to be looking more at graphics on the Atari 8-bit, and we're going to move this box around with a joystick, and we're going to do a little bit of sound. And that'll be the third Atari 8-bit one, and then we're going to move on to something like the ColecoVision, which I think there's more support for sprites. We're going to maybe look at MSX and Commodore 64, maybe VIC-20. Just try a bunch of different ones. How we get this basic code to work with this box, moving it with the joystick. How do we refresh the screen? If sprites are enabled on the other systems, that'll look a little bit better. And then we'll come back and we'll see what we can do to make a little game. It's not going to be great, but we're going to be figuring out what can we do in ugBasic on these 4 or 5 machines. Maybe Coco in there too, if we can. I'll see what's... I forget if Coco's in there. That's it for this time. Have fun playing with your favorite BASIC on your favorite machine, and look up some ugBasic and play with it and give me some comments. Let me know what you see. Next time, if there's any comments, I'm going to talk about the comments before we start this the next video. And then play with it, let me know what you see, and have fun playing with your favorite BASIC in the vertical blank.
We were children of the Silicon Revolution, an X generation conscripted to fight the console and home computer wars. A product of an analog 70s childhood, we came of digital age in the 80s, believing we could affect the world 8 bits at a time. Armed with joysticks, full-stroke keyboards, Jolt Cola, and MTV haircuts, we proceeded into the vertical blank. There, we stayed up late at night, devising incantations from D&D rulebooks and beginner's all-purpose symbolic instruction code. Video games were the match, and programming was the fuse, as the infinite possibilities of the digital world exploded into the internet age to come. We are Generation Atari.
Into the vertical blank.